Hi. So back to English. Hi, I'm Omer. I'm a staff software engineer at WeWork. I've been with WeWork for under a year. Not gonna do a self-intro because that's meaningless. So let's just kick off with something extremely positive. Everything is terrible. Yes, software is amazing these days. Some of you may know this graph. This is a graph of throughout the software's development lifecycle, how much does it cost to fix an issue, right? How much does an issue cost us? So we can see things from requirements through design, acceptance tests, operations, and so on. So there are two things I want you to notice about this graph, right? Does anyone know this graph? Okay, so very few people. Two things that I want you to notice. One is that this is a logarithmic scale, so that it exponentially increases in cost. This is cheating, right? And the second thing I want you to notice is this is from 1981, right? So we've known about this for a while now. But we have unit testing, and unit testing is awesome. So it helps us find those problems really early in the software development lifecycle. It helps us refactor your confidence. It brings confidence into the software development lifecycle. Who here doesn't do unit tests? Excellent. It helps us also document our usage, right? We can read the unit tests and figure out how to use the code. But they are also less awesome because they are more code that we need to write and review and maintain. That's so much code. There are code bases where it's 6-to-1 ratio testing code to actual production code. And we are, in essence, writing more code. You know what it is to read code, what it is like to read code. It's much easier to write it than to read it. And unit testing is code. And are they exhaustive? Have they tested everything? Have we tested everything? Do we have any way of knowing that we've tested anything? 100% coverage is a lie, right? It just says, yes, we have covered our asses with regards to the specific unit tests. Maybe we haven't tested everything. We don't know. We just have a metric that's a number randomly. And tests are poor documentation because they are code, and it is really hard to read code when opposed to reading actual text. When someone tries to explain it to you and say, here, this is what this does, instead of go read my code that is 6 times longer than the actual code. So another thing that we are seeing is that there's divergent behavior, right? Let's see an example of that. We have a comment here that says, this is probably a function, right? A method or a function that connects a cat to all veterinarian clinics. It receives a parameter that's the cat ID, and it returns the number of clinics that have been connected to that cat. Awesome. Now let's read the function signature. That doesn't really look like what we've just read, does it? Something has changed over time, I guess. Let's read the Git history to figure out what it is. And there is tests, like this, a cat may not be associated with more than one clinic. I'm not exactly sure how I could understand that from the documentation, or do I need to read the tests? And are there any exceptions? Will I get an exception if something happens? What happens? How do I get, which exceptions do I get? So I don't know anything about that, and we need to increase confidence, right? Further than what we can do with what we've seen so far. So what if we could enforce some invariant business rules, things that we know are not gonna change, or at least if we do change them, we're gonna pay the price for that, right? And we'll use that using an automated tool to increase that confidence, right? An automated tool will check it, like, linters, for instance. And then we could replace those really basic, really repetitive validation tests and documentation, because that tool will check it for us, right? This wonderful, beautiful tool. We could discover those failures much earlier, because while we're writing, that tool will validate that we have made a mistake or done everything correctly. It would impact our code users, because if I'm writing an API for someone else to use, then that person would get that checking through the tool themselves, right? They would get that benefit as well. And we could explicitly understand where validations happen. So if I want this to be a cat, then I can understand where that transitions from a something into a cat explicitly. So let's see a little demo of that. So this is a calculator that I've written in Scala with a lot of abominations to make it less Scala and more understandable, more readable. This is a calculator. This calculator gets a list. Let's read the docs, right? It adds up a non-empty list, at least one element, right, of natural numbers. That means we have positive integers, right? So what do we need to test? Let's look at the tests, right? We should check that the input is valid and throw an exception if the input is null, right? If it's null, we don't want bad things to happen, so let's throw. If it's a string, that doesn't make sense. We said we wanted a list, so that should fail. If it's just a number, should fail because we wanted a list, right? Come on, give me a list. If it's an empty list, that's nil is an empty list, that should also throw an exception because it's supposed to be a non-empty list, right? One of the prerequisites for running the function. Also, if there's a null inside one of the elements is a null, we should make sure that that is taken care of. Sure, that's another test. Right, so we should also throw if there's a string in there, or if there's a string and a number, if there's a non-integer, just a double, yes, throw. If it's a -1, sure, throw. It's supposed to be at least like a 0, above 0. And if there's only one negative number, we should also throw. So there is a lot of tests here. Does this look exhaustive to you guys? Awesome, so let's run this and see. This is taking a little while because it's been a while since I compiled this code, because Scala is a compiled language and this is going to take a moment. Right, so it's running tests. Yay, 11 tests passed. That means that my code is really, really well tested and probably works, because well tested and works doesn't necessarily correlate. But I don't want to do all of these checks because here, look at this. We're testing that it's all of these tests. Is it a null? Is it a list? Is it empty? Is every item an integer? Or is it 0 and above, or whatever, less than 0 or equals 0? Where is the business logic here? It's lost in the sea of checks, of ifs. So let's try and use those magical annotations that are types, right? So let's start off with what is any, right? Any means it could be anything, right? I don't care. Just don't check. When instead I want to say I want a list, right? I want to make sure that this is a list. So let's say it's a list of anything, right? Let's try and run the tests again. I think that's the one. Okay, so this is the compiler. This is the automated tool that I'm using, and it's saying, sure, fine, but you're making a mistake. You said you wanted a list, you're giving it something that's not a list. That just can't happen, so the tests are failing to compile. So I've not even run the tests yet. So let's throw away these two tests because they cannot happen anymore. This code just can't happen. It can't exist in my code base. Right, let's shift F9. Right, let's run the tests again. Works. Have I lost any confidence in my code by deleting two tests? No? Okay, awesome. That's where we're aiming for. Awesome, so now I don't, so here, there's is this a list? I don't need to check this anymore, right? I can delete this code. Awesome. Delete this code, run the tests again. Works. Do you say it works? Awesome, works. Now, I don't want to test that everything inside of this is an integer, right? I don't want to test this. This is silly. I just want to say that the compiler needs to test that everything is an integer, right? And as a result of that, I also want my function to return integers, because if I'm summing up integers, I'm returning integers, right? Cool. Let's run this. Right. I can't run these tests anymore. They just don't, they won't compile, so I don't have them. So can I delete them? Yeah, I guess so. Done, 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 done. Awesome. Let's run this test. So, well, right. So one of the I did some wrote some abominations into the code to make sure that it compiles without all the types. Some of them have probably fired back. So I can't run the code. Would you would you believe me if I said that everything runs? I assume yes. So let's delete the code. Right. So this can't happen anymore. Right. Sweet. Another thing that can't happen anymore is that it equals a null, because integers can't be nulls in this specific case. So bye. Cool. Less tests. Probably work. Sorry about that. Next up, I don't want to test that the list is empty. I want to know that the list is not empty. How do I do that? Sorry? Non-empty list. How does that work? Cool. I mean, cool. That's a cool name for a type. But how does it work? Okay. So a non-empty list would need at least one element, right? So I can say it's a class with a single member that says it's the head of the list, and another list that says it's the tail. So that list can be empty, sure, fine, I have at least one element. So let's use a non-empty list. Cool, I don't need this test anymore. Cool, right. Now there's a problem here. Who can tell me what the problem is before I try and run everything? I need to pass a non-empty list instead of a list. That's also true, but for this code specifically, can I assume, so as I said, what is the non-empty list? It's a class with a head and a list, right? So I can't for each over it, right? Because it's a class, it's a new kind of class, right? So what I do is I take maybe a list of somethings, which is no longer a list of something, it's a list of ints, right? And take the head element as the first element, right? And I want to check that it is also, right? It has to be greater than 0, right? Everyone with me? Cool. And now the list of ints has a tail, which is just a list, right? So now I've just taken the first element, and I could just have a loop that is empty. It just doesn't run anymore anyway if there's only one element. Cool. Let's run this. Okay, so I need a non-empty list, right? In this case, I can just non-empty list of this. Cool, that works. This is an empty list, so I can't really send that anymore into the function. So bye-bye test. Right, this is a non-empty list, non-empty list, and non-empty list. That's pretty much it, right? Let's run those tests. Again, bitten by my own abominations. So those are 5 tests, and they succeed, right? You'll believe me. And I've whittled down the number of validations, right? Just by adding those annotations. Cool. Now I don't want nulls, right? I don't want nulls. Let's tell the compiler we don't want nulls. Sure. No nulls. Language doesn't have nulls anymore. Yay. It's like, sure. How does that work? Right, so the compiler is pluggable, and it's a tool that's linting my code, right? And it's pluggable. I can just give plugins. And one of the plugins is a linter that says, yeah, you can just avoid nulls by disallowing them entirely. Cool. if I run this code, hopefully I can run this code, or let me see. Okay, so I would get the exception that an error from the compiler that nulls are no longer allowed. Cool. No nulls, by nulls, and I can remove the null checks. Cool. What else do we want to do? Which other validations can I get rid of? So positives. Is there any way for me to check that something is a positive? Posint. There's no posint, but nice, nice try. So something that exists in Scala specifically is refine types. I want to refine my integers to be positive. I want a compiler to check for that. So let me just add the code to do that. Cool. Int refined positive. So can I assume from that my response will always be positive? Is that a valid assumption? I am summing up positive numbers. Yes. Cool. Bye. Bye-bye. Awesome. And now I have an error. Why do I have an error? Because I am trying to send in integers and not positive integers, not integers refined to be positive. Sure, so let's just import this thing that automatically says if it's an integer that's positive. Sure, it's a positive integer, right? Cool, let's run this. Hopefully it runs now. Right, compiler now says -1 is not greater than 0. I'm not gonna run this code. That's it. Just, I'm not gonna run these tests. So my tests don't even start, and I already know that they have failed, right? Cool. So let's delete the remainder of our tests, almost all of them, and run our single test. And we have one test instead of 11 that preserves the level of confidence that I at least had in our code. Does everyone else feel that the level of confidence that is in this code is equal, at least, to the level of confidence we had with the 11 tests? Okay, cool, awesome. And a side effect of that, a nice side effect of that, is that I can see the forest for the trees, right? There are no validation checks and no ifs. No, my code was littered with ifs. Let's compare. Let's do a comparison. This is the amount of code that I used to have, and this is the amount of code that I have now. Cool. So everything was durable. Is this a silver bullet? I think you've already seen the answer to that. No, there are no silver bullets. Please, this is nice, but it's not a silver bullet. What about Ruby? This is a Ruby meetup, right? So before I talk about that, I'm gonna just share one thing with you. This is Kent Beck's 3x model. Who here knows this? Okay, so one person. Cool. So this is the lifetime of a system that has succeeded, right? So we're starting out with Explore. We're trying to explore what we should be building even, right? What's the business? What's the domain? Then we've hit it off. We're expanding, right? We're growing at a huge pace. You can see that the payoff is increasing really rapidly. And then we get to a point where we're plateauing. We've already gotten to a point where the ROI is is low enough for us to stop expanding, and now we're extracting the value out of that system. We're adding small features, we're adding, fixing lots of bugs, maintaining the system, and so on. So where does dynamic typing fit really well into this? It's there in the explore and expand phase. It's there when you don't know what this thing that you have in your hand, this variable even is, right? It can change tomorrow. There are little to no business invariants. Everything can change tomorrow, right? The CEO can come in and say, right, hello, good morning, startup. We're shifting direction like 90 degrees to the right. Greenfield projects, things that are new, unexplored, we don't know a lot about them. And when maintainability is less important than delivery, right? If we are thinking about how we can push features as quickly as possible, rather than how we can later maintain this code, then this is a great way, a great direction to go. Dynamic typing becomes painful when you have a very large system that you're extracting value from. You're fixing bugs, you have teams that are growing, you have so much pain in refactoring where you have to test the hell out of a component before you're satisfied that the refactoring actually succeeded. And those tests don't necessarily exist before you started the refactoring. The foundations that you're building on are probably shaky because you had to run really, really fast in explore and expand. And there are business invariants in your code that are undocumented. You're reading this if, why is this if here? I don't know, it was like 3 people before me, and the product manager doesn't even know that this exists in the product, right? So that's where typing really helps. So we're always using types for everything? No, types are better at validations, at the very simple things like you saw, positive integers, sure. Is this an IP? Cool. Is this list empty? It's not empty. And tests are much better at business logic. You saw that we left one test, and that test was, is summing up positive integers, does it work? Right? It's testing the core logic. And integrations, because integrations go outside of where the compiler has any influence and any understanding of what's going on. If I'm connecting to the database is not part of my type system. I don't know how to even check without all those conditionals. Types and unit tests are limited. As I said, they can't go outside those code boundaries, outside of, let's say I'm running inside a VM, a languages VM, right? I can't go outside of that because I can't control all the things that happen outside of it, all the side effects that happen. What we can do is we can use better abstractions. We can use libraries that promote those kind of types into our code and take care of all those if-elses and all those exceptions that may be thrown by the system. To sum it up, we've increased our robustness and confidence because we're writing less code and maintaining the confidence, so it's better, right? We're failing fast. You saw that before I even ran any of my tests, I knew that my code for the tests won't work, and like that, the code that would use my code and not just the tests just won't compile. They won't work. They won't even start running. And we have more focused tests and documentation because you don't need to tell the person who is writing the code that is calling the sum all positive integers function that they need to pass a non-empty list of positive integers because they can't do anything else, right? That's it for me. And any questions? Right, so the question was, how do I apply that to Ruby? The short answer is you can't, because Ruby is a dynamically typed language. But I keep saying that over time, as a language becomes more and more popular, the probability of it having a static type checking compiler approaches 1. Right? Because more and more companies are using it for bigger and bigger projects, so the probability of it ending up with a type checking compiler increases. So Ruby has had several attempts at some people have tried creating type checking compilers. None of those have succeeded so far. The most promising one and as far as I know, only living one is Sorbet, which is a Stripe project. It is not public yet. I've heard very good things. But you can see this also in other languages. For instance, Python is adding type annotations, and JavaScript has Flow and it has TypeScript, which are the two biggest projects in that area, right? And I'm really hoping that Stripe does release Sorbet soon. But once that happens, we will get to a point where libraries can be written on top of that to create those abstractions. Thank you.